We want to start figuring out what tables and columns we've got in the underlying database of this application. And there are a couple of different ways of doing it. And one way is we can do it in a very manual, somewhat laborious way. We're going to make this much more automatic as we proceed through this module. But I want to start here because it's the most basic, simple to understand one. So here's what I'm going to do. Let's add a little injection attack to the end of this URL. And I'm going to close off this parameter, and then I'm going to put an AND statement. And now what I want to do is say 1 equals, then in brackets, select star from foo. And of course, comment out everything that is left. Now this is a syntactically correct statement. So think back to the previous module when we looked at what the SQL query looked like. We've simply closed off the string that is v12, added an AND clause, and now we've got an equivalency test. So select star from foo must equal 1. Here's the thing though. We're guessing foo, so what's going to happen when we run this statement against a table that probably is not going to exist in the database? Let's find out. We get an exception, but more importantly, we get an exception that is telling us something. Invalid object name foo. The website has just told us that there is no table called foo. This is really valuable, and this is how we use error-based SQL injection to start discovering this underlying schema. Now, of course, foo was always going to be a pretty infeasible table. Let's now change this to something a little bit more likely. Something like user profile. And we'll run that. So now we get a very different sort of error. So the website is no longer telling us that the table doesn't exist. We've got quite a different exception. Only one expression can be specified in the select list. So think about what's happening here. There is actually a table called user profile. We are selecting star from user profile. So we're going to have a collection of columns across a collection of records. And we're trying to see if that is equal to 1, which it never will be. You can't compare a result set with the number 1. You must have one expression in the select list to compare it with the number 1. So now that we know the table exists, we can move on to the columns. So let's change star, and we'll change star this time to bar. And this time we get another confirmation. There is no column called bar. So we're discovering very quickly, by process of elimination, what objects exist in the database. We did that with the table, now we're doing it with the columns. So something more likely to be found in a user profile table is going to be password. Let's do that now. We'll change bar to password, and we'll run that. Okay, different error again. So password does exist, but now we've got a different problem. Now we've got many different rows with one column each. And what the error is telling us is that the subquery, so that's our query in brackets, is returning more than one value. And of course it is, because there are going to be multiple rows. But as we saw earlier on in the course, when we went through some fundamental SQL syntax, it's easy to just get one row. We're just going to get the top one. So we'll do this. Let's now run this one. Now we have something that is genuinely useful. We have this. We have an internal data value. The first password in the user profile table is the word password with a 0 instead of an O. And the reason we're seeing this result here is because SQL Server is trying to compare the word password to the number 1. So that's what's up here in our statement. Now, of course, you can't compare the string password to the integer 1. So you're going to get a conversion failure. And that failure is bubbling up to the user interface because the error handling of the application is not right. It's leaking those internal exceptions. Now, one thing that's worth pointing out here, and I did actually point this out in the last module too, what this exception is showing us is that not only do we have a SQL injection risk in this application, but it is doing a terrible job of storing passwords too. That's a clear text password. That is not a nice strong cryptographic hash of a password as it should be. Now that's a bit tangential, but I did just want to take this opportunity to point out why that is so important, because a risk like this can get access to that underlying storage. So here we are, process of elimination. We've discovered tables that exist, we've discovered columns that exist, and we've actually exfiltrated some data as well. But this was a bit of hard work. We did have to start guessing what things were. And whilst that will usually yield some positive results, it's also all a little bit too much like hard work. So let's move on and have a look at how we can actually query system objects to discover the schema. Let's go check that out now.